Finance Unit, Section 2, Computing Compound Interest Using the Compound Interest Formula. This is the compound interest formula, where A is the total amount in the account. This would be the combination of the principal and interest. P stands for the principal amount, the initial amount that's invested. R is the interest rate as a decimal. T is the time that the amount is in the account and being compounded in terms of years. N is the number of times interest is compounded in 1 year. So here's our first example. You will invest $250 at 2% interest compounded quarterly. How much money will be in the account after 3 years? So here's our compound interest formula, and we're going to replace the indicated variables. The principal is the amount that was invested, that's $250. Lowercase r is the interest rate expressed as a decimal. This account is paying 2%, so we put 0.02. And the letter T here is the time. It says this money will be in the account for 3 years. Next, we're going to put a value in place of n. This problem says that the interest is compounded quarterly. Quarterly means 4 times per year. So in place of n, we'll put a 4. Out here, the n next to the t and this exponent means to multiply those two values together. So we'll replace that 4 times 3 with a 12. We're now ready to get a calculator to enter this formula in to determine what the value of it is. So here we have a graphic showing you a TI-30XA model calculator. Virtually any scientific calculator will work, and essentially what we're going to do is we're going to enter the information just the way it looks here in the formula. We have 250 times parenthesis 1 plus 0.02. The fraction bar means divide, 4, and paren, and then we have 12. That's an exponent, so we have to use our power key on our calculator. On this model, our power key is right above the division sign. There's an enlargement of that. Other calculators, it might be an x to the y, or it might be a caret, which is an upside down v. And then we'll enter the number 12, and finally, to calculate this value, we will enter the equal sign, giving us a value of $265 and, rounding to the nearest cent, 42 cents. This is the amount of money that will be in the account after the 3 years, with the account compounding quarterly and paying 2%. Let's look at another one. You will invest $600 at 3% interest compounded monthly. How much money will be in the account after 5 years? Here's the compound interest formula. We'll replace each of these variables indicated with the information from the problem. They're investing $600. That's our principal. The interest rate as a decimal is R, which is 0.03, and this money will be in the account for 5 years. That value will replace T. Next, we need to determine the value of N. That corresponds with the number of compounding periods. This problem indicated that the money will be compounded monthly, and monthly is equivalent to 12 numerically. Before we enter this into our calculator, we do want to simplify this exponential power into a single digit. So 12 times 5, we're going to replace with a 60. We're now ready to enter this into the calculator, and the same steps as in the last one. We start with the first number, 600. It's an implied multiplication, but we're going to be sure that we tell the calculator that it's multiplication. Then enter the parenthesis, 1, plus sign, numerator 0.03, divided by 12, end paren, and this 60 is an exponent, so we need to hit our power key on our calculator and enter the exponent. To do the calculation then, we're going to hit an equals, and rounding this to the nearest penny, there's nothing to alter that 7, so we'll leave it as $696.97. Our third example says you will invest $400 at 1.5% interest compounded daily. How much money will be in the account after 2 years? Using our compound interest formula and gleaning the information from the problem, we're going to replace the principal with $400, replace the interest R with the decimal equivalency of 1.5% or 0.015, and 2 years will replace the value of T. Next, to replace N, the number of compounding periods, we look to the problem. It's compounded daily. Since there are 365 days in a year, we'll replace N with the 365. This N next to the T is an implied multiplication, and before you enter this in your calculator, do simplify this to a single number. So 365 times 2 is equivalent to 730. We're now ready to enter this in your calculator, the same steps as previously, 400 times parenthesis and so on. And after entering that in, hopefully you get $412.18. You are now ready to try some problems on your own with practice set 7 found on page 26.